Next topic is the cavitation. So I would like to show you a clips about the cavitation to explain more clearly what's going on, what happened with what is phenomena, what kind of the cavitation.
If a propeller spins quickly, it leaves a trail of bubbles behind it. As the bubbles pop, they make a lot of noise. These bubbles are not filled with air, but with steam. The steam is produced by the seawater boiling.
It is a well-known fact that water boils at 100 degrees centigrade. However, few people will know that at different pressures, the water will boil at different temperatures. If you increase the pressure, as in a pressure cooker for instance, then the boiling point of the water increases. Hence, the cooking is more efficient. Few people will know, however, that at reduced pressures, water will boil at lower temperatures. I have here a vacuum pump and I'm going to turn on the vacuum. This flask here contains water and we have it connected to a pressure gauge and we're reading at the moment approximately 15 pounds per square inch, which is 1 atmosphere. I turn on the pump, you notice the pressure dropping immediately, and as the pressure drops, as we approach zero, bubbles start to form and the water starts to boil. So here we are at room temperature, but at a significantly reduced pressure, almost a complete vacuum, the water is now boiling. Water boiling at 20 degrees centigrade at almost 0 pounds per square inch, a remarkable phenomenon, sir.
When a submarine's propeller turns quickly, an area of low pressure is created on the blades. This lowering of pressure causes the water to boil without heating up and produces bubbles of steam. This is called cavitation.
The formation of those bubbles is dependent on how fast we rotate our propeller. So the faster we go, the more risk we are for cavitation.
The Pennsylvania's propeller design is a closely guarded secret, but the basic principles of a quiet running propeller are known. Cavitation only occurs when a propeller spins quickly. Slowing the propeller down reduces cavitation and therefore noise. But slowing the propeller also reduces a submarine's thrust. To overcome this problem, the Pennsylvania's engineers developed a unique propeller with 4 additional specially shaped blades. These generate large amounts of thrust, but at much lower speeds. This way, the Pennsylvania produces almost no cavitation or propeller noise. She is a silent predator of the deep.
Okay, you may understand clearly what is the cavitation. Okay. The definition is simply defined that cavitation is the formation of the bubble or cavities in liquid developed in the area of relatively low pressure. You can see in the experiment around the impeller. In this case, we are impeller of the pump, but in the clip is the impeller of the submarine. The imploding or corrupting of this bubble trigger intense shock wave inside the pump, causing a significant damage to the impeller and all the pump housing. Okay, how to prevent the cavitation? First is a pump selection. The best way to prevent cavitation is to select the right pump for the application. Cavitation increase as the pump head fall or as the capacity increase. So selecting the correct pump to maintain the positive margin of the suction head available above suction head required is the best first move. Okay, the second, addressing the distant discharge cavitation. Discharge cavitation occur when the pressure at the discharge end of the pump is too high. Okay, high discharge pressure limit the volume of fluid flowing out of the pump, causing a high velocity fluid. Okay, and the third method is to routine pump maintenance. Check the filter and strainer access entire pump system design. Evaluate the curve, monitoring pressure sensor equipment, looking for the cracks and collapse piping or lost hose that will disrupt the system. And the fourth is proper installation, okay, to maintain the net positive suction head available greater than the suction head required by consider four key factors. One is pump location, suction pipe length and diameter, suction lift, and the friction loss. Okay, this picture shows how cavitation damage on the pipe casing.